Here we are on to section 2.4, quadratic transformations and diagnostics. What does it mean to transform a quadratic? You've learned about transformations before in your math classes, and today we're going to focus solely on transforming a quadratic. So what I want to do is start with note card 57, the quadratic parent function. Now, parent function, another way you could say that is mother function. But we're just going to say parent function, okay? So the quadratic parent function is the non-transformed graph of y equals x squared. And this is what the graph looks like. Its vertex is 0, 0, and we've got beautifulness happening. It's symmetric about the y-axis, and it's just the perfect parabola. Now, let's do the diagnostics. Of course, the vertex is 0, 0. The equation of the axis of symmetry is x equals 0 because that's the vertical line that goes through the x-axis, x equals 0, and it goes through the vertex. Now, what's the domain? Well, for any parabola that opens up or down, the domain is negative infinity to infinity. Now, what's the range? If we were to smush this green graph to the y-axis, what would be covered? Now, remember the range, we go bottom to top. So the bottommost y value is 0, and the topmost y value is infinity, because it keeps going forever. So your range is bracket 0 to infinity. Now remember, range is the only diagnostic that you use the y values, okay? And it's the only diagnostic that you look from bottom to top. Now the next thing I'm going to ask you is, where is this parent function increasing? And that's when you look from left to right where it rises, and that's happening from here on. Now you notate it with the x value, so it starts at 0 and goes on to forever. And increasing and decreasing, you do not use brackets, so it's going to be parentheses 0 to infinity. Decreasing starts at right here, starts way over here, and then it decreases all the way to the x value of 0. So that's left to right. It's negative infinity because it goes on forever this way. So negative infinity all the way up to 0. And again, we don't use brackets with increasing or decreasing. All right, positive means, where does this thing live above the x-axis? Where does it live above the x-axis? Well, this thing, you might go, well, Miss Sharp, it's everywhere. It's negative infinity to infinity. This thing does not live above the x-axis all the way from negative infinity to infinity. What's happening at 0? At x equals 0, y is 0. Y'all, the y values have to be positive in order for it to be positive. And so, yes, y values are positive here, y values are positive here, but not here on the x-axis. So we have to split it with a union. It's positive from negative infinity all the way up to 0, because at 0 it's neutral. It is not positive. Union 0 to infinity. Seems really odd, but I wanted to show you that. Now, where is it negative? It's never below the x-axis. So I put NA for not applicable. So pause me and finish your note card 57. All right, now, I want to answer the essential question. What does it mean to transform a quadratic? It means to move it up, down, left, or right from the parent function that we just talked about, and that's called a translation, when we just move up or down, left or right, okay? That's called a translation. It means to reflect the parent function from the parent function. It means to reflect from the parent function, y equals x squared. That's called a reflection. A reflection of this would be where it opens down. It means to stretch or shrink from the parent function. So make it wider or make it thinner. A vertical stretch or a vertical shrink. It's called a dilation. Now, this is a little thing that is just generic for transformations of functions, not necessarily specific to quadratics, but the rules still work. So I wanted you to have that. I'll be referring to it. This is what I will be referring to mostly today in this lesson. So this is note card 58, yes, but I want you to wait to fill out the note card till after I explain it to you, okay? So we know vertex form because we're going to be translating or transforming or dilating or reflecting with vertex form today with parabolas, okay? So y equals a times x minus h quantity squared plus k. A tells us a lot. We know that if A is negative, the parabola opens down. We already know that. But that's called a reflection over the x-axis. So look, remember, if it opens down, we'd have to have a negative in the front of that. Now we have a little bit more in this blue box that we need to talk about. If the absolute value of A is greater than 0, so let's say we had a negative 10 in the front. Take the absolute value of that, it's 10. Or we had a 9, or a 5/2, because that's 2.5. All those are greater than 0. Then we have what we call a vertical stretch of the parabola, and the parabola would narrow, okay? If the absolute value of A is between 0 and 1, so 1/2, 2/3, 0.4, 0.9, 0.6, 0.1, 0.002, any of those, if that number out front is between 0 and 1, the absolute value of A, there is a vertical compression or shrink. You could say that either way. And if you have a parabola and you compress it vertically, it is going to become, I think it got frozen. Hold on. I don't know what's happened to me. On my screen it's frozen. I don't know if it's going to be on yours. But when we have a vertical, there we go. When we have a vertical shrink of a parabola, it's going to make it wider, okay? So it's not going to narrow. The stretch is going to narrow it, and the shrink's going to make it wider. And that's all about A. Now let's think about H. This is inside the parentheses, and this will yield a horizontal translation, so left or right. If you have an x minus h, so it has the minus in there, it's going to be right h units. So it's going to translate to the right h. If you have an x plus h in there, it's going to translate to the left h unit. So it's kind of opposite what you would think, okay? Now the k, that's outside. It would be a vertical translation. It's going to go up k if there was a plus k, so a plus 1, be up 1. It's going to go down k if it's a negative k. So if I had a minus 1, it would be down 1. So now pause me and write all of this down. Okay, good. Now we're on to some examples where I want you to state the transformations. I know some of you rushed to get the note card out and to get it finished, but I really wish you would just wait and listen, and then at the end of this, pause. At the end of me going over this, pause and write down your note card. So let's look at this. These are all in These are all in vertex form, and we want to state the transformation. So you need to have your note card 58 handy, okay, as we're doing these, and we can look at this and see. A in front of this is 1, so I don't have to worry about any kind of dilation. I don't need to worry about any stretching or shrinking, okay? But I do have something inside. I have an x minus 3, and this says if it's inside and you have an x minus, you're going to go right that amount. So we're going to go right 3, and that's a translation, okay? Left, right, up, down are translations. And this has a plus 2. That's in the K spot. If I have a plus out here, if it's a plus something, it goes up that amount. So it's going to go up 2. Now let's look at this one. Sort of similar, except we have an A value other than 1, and we've changed some signs. So let's see. It's going to go left 3 because it has an x plus 3 inside the operation in the parenthesis. So an x plus 3 would mean that you're going to go left 3. What does this mean? It's a minus 2. This says if you have a minus k, it goes down that amount. So we're going to go down 2. Those are both translations. But we have another transformation. So transformation is the umbrella term for all of these things. There's a you got the umbrella, you got translations, dilations, reflections, okay? So this 2, and let's look. 2 is greater than 0. So we're going to have a vertical stretch. And the way we write that is we have a vertical stretch by a factor of 2. All right, now over here, what is happening here? We've got a negative out front. Y'all, that negative out front means we have a reflection. We have a 1/3. Now we do the absolute value of A. So that 1/3 it's negative 1/3, but do the absolute value of it. So it followed this one. We're going to have a vertical compression or shrink. What else? This is going to be right 2. Look back at your note card if you need to. This is going to be up 4. So look, right 2, up 4. Both of those are translations. we do have a dilation. We have a vertical shrink by a factor of 1/3. Okay, and it's reflected over the x-axis. This one over here is also going to be reflected over the x-axis because we have the negative out front. Okay, I'm going to go ahead and do the blue one. I know it's out of order, but no, I'll wait. All right, so the green one. A is 1. There's not a reflection, so we're going to go right 2 and down 4. Right 2 because we do, if it's an x minus 2, we do opposite what we think inside the parentheses. So it's right 2 and then down 4. This one, it's going to be left 2, up 4. So left 2, up 4, and it's going to reflect over the x-axis because of that negative. So now pause me and finish up note card 59. All right, so I want to look at this one. So with state the transformations, we've already actually done this. This was the first one you did on the last note card. And then I typed it into Desmos and grabbed me a quick little screenshot of that. And we can see that it went right 3, up 2, so our vertex is 3, 2. So not only are we going to be transforming, because remember the title was Transformations in Diagnostics, you're going to need to be able to diagnose these things. So now that we've translated it up and to the right, so we took the parent, which was right here, it went right 3 and up 2. So all we did was just move that parent function around. Now it did not have any dilations, so it is not going to narrow or widen at all, and it didn't reflect. Okay, so we need to be able to do all of diagnostics. So we know the vertex. These two should be pretty straightforward. The vertex is 3, 2. Our axis of symmetry is this vertical line right here that goes through the vertex. And so if I drew in that vertical line, then I could smush the two halves together and they would be symmetrical. But this would be x equals 3. Now, the domain. All of these parabolas that open up or down have a domain of negative infinity to infinity. Oh my, hold on. All right. So now, let's talk about range. Now, the range is the only diagnostic that you do the y values. It's the only one that you do that. And you go from bottom to top. So it is bounded below. It doesn't keep going below. So my bottommost y value is what? My bottommost y value is 2. And then what's my topmost y value? There's not one. It's unbounded. So that would be infinity. So the range is bracket 2, because that's the lowest y value, comma, span to infinity. Now, looking at this graph, where is it increasing from left to right? So right here, it looks like it's decreasing, and then it starts increasing. So I'm increasing. Now, this is where we go back to x values. We're back to notating with x values. So you're increasing from this x value of 3 and on, forever and ever and ever. So that'll be 3, comma, infinity, and you will not use brackets with this because, and here's why. You can't put a bracket at 3 because you can't increase. That'd be saying that you're including it on the increasing interval. You can't actually increase at a single x value. So I can't do that. It has to be a span that I increase. Now, the decreasing is here to here. So what is this concept? Remember, you're looking at x values. It's going to keep going like that. So that's negative infinity. Those x values are negative infinity. If I were to smush this down to the x-axis, all right, so negative infinity all the way to 3. No brackets. All right. Now, where is this thing positive? Where is this thing living above the x-axis? And that would be all the time. This thing is never going to be below the x-axis, so you're positive all the time, which is negative infinity to infinity. And where is this thing negative? It's not. It's not. You can put not. I just put not applicable. Okay? So now let's look at another one. Let's look at this one. So I basically took the same graph and I did some other things to it. Well, from the parent function. So let's first talk about the transformations, all right? There's a negative in the front, so that's going to be a reflection. Guys, that means it's opening down. That means we're going to have a maximum value at the vertex. And then it goes left 3 and up 2. So there are your transformations. I typed it in Desmos, got a graph, and we are going to actually be using Desmos with this section. I know. We need to get used to that calculator, but I just wanted to use Desmos just for ease, right now, okay? Okay, now I do see that I've got some decimals. You just write them as you see them when you're doing the diagnostics. All right, so we're doing the diagnostics. What's our vertex? Well, it is negative 3, 2. It's an ordered pair, negative 3, 2. What is our axis of symmetry? It's x equals whatever the x value of the vertex is. So it's x equals negative 3. What's our domain? Well, it's a parabola. It's opening down, so it's negative infinity to infinity. The range. This is where we go to the y values, and we go from bottom to top. This thing is unbounded below. It keeps going. So that's negative infinity all the way up to the topmost y value. What is that topmost y value? It's 2. So negative infinity up to 2 with a bracket on it because that 2 is included. All right. Now, where is this increasing from left to right? So look. So what's happening? What's happening there? It's increasing. So if I were to take just this part that I am hovering over, which is the increasing part, and smush that to the x-axis, if I were to do that, let me try this again. I tried this the other day and it was a hot mess. So let's see. Ooh, yeah. Okay. So if I were to take this and smush it to the x-axis, it would start at negative 3 and all of this would be covered. All of that. So what is that in interval notation? Well, let's see. I obviously have not mastered the drawing tool with this, but anyway, that would be negative infinity up to the x value of negative 3. So it'd be all of that, okay? All of that. All right, and then where would it be decreasing? Well, that would be everywhere else. So negative 3 to infinity. So if I smush that down, it'd be negative 3 to infinity. All right, where is this thing positive? Well, this thing is positive when it lives above the x-axis, and that's from here to here. So from negative 4.14 all the way to negative 1.586. That's your positive interval. Okay, that's where it is above. Now our negative interval, there's going to be 2 of them. This one and this one. And I have to notate them with the x value. So I can imagine taking this right here and smushing it up to the x-axis. That would be all of this. So we got to go left to right. Over here's the concept of negative infinity all the way up to that negative 4.14. And then a union, take this part right here and smush it up. So it'd be this, negative 1.586 to infinity. That's a lot. That's a lot. So I'm actually going to add in that this was supposed to be a note card. So hold on just a second. There we go. So now I want you to click pause and I want you to do your note card 60. Make sure you're taking the time to, when you draw the parabola, it doesn't have to be perfect, but you need these points on it. When you draw it on your note card, you need to write down your transformations. And then on the back or on the side, fill in these diagnostics. If you can believe it, we're almost on the last note card. Well, we are. So here's the last note card. It's another example. It's note card 61. Can you believe we have 61 note cards? I can. We're going to have a lot, okay? And they're going to be a great study tool. But anyway, given this, let's state the transformations. Can you tell I just had supper? All right, so we have the 2 out front. What does that do? Let's remember from note card 58. Whatever this is, out front, you do the absolute value of it, and it's greater than 0, which it is. If it is, it's a vertical stretch. These are dilations. It's a vertical stretch. So we have a vertical stretch by a factor of 2. This is left 3, because this says if we have a plus h, it goes left that amount. So this goes left 3, and we have a minus k, so it goes down 2. So there are your transformations. Now remember, This is a dilation, that 2, and we say vertical stretch because it's bigger than 1 by a factor of 2. I typed it into Desmos and I got this nice little graph, okay? I couldn't quite get these ordered pairs to go where I wanted them to, but like I wanted this one on the other side right here, but it wouldn't do that. So this is -4, 0, that's -2, 0, and this is -3, -2. Now, again, I know a lot of you like to rush to get your note cards finished. I'd rather you just listen to me, because let me do my job, okay? And then you can finish your note card. So the diagnostics, that's what we're moving on to. This is so important. The vertex, we got it. It's -3, -2, okay? That's right there, -3, -2. What is our axis of symmetry? It is this vertical line that would split that directly in half. It goes through the vertex, and it's x equals -3. All right, now we get to the nitty-gritty. Domain. With any of these parabolas, the domain's -infinity to infinity. Why? Because if I were to smush each of these little pieces to the x-axis, all of it would be covered. All right, now the range is what always gets students. Always, always, always. This is the one where we look bottom to top. Bottom to top. And when you guys did your 2.3 interactive worksheet, I had the little tricks here for all of this. So the range, we notate with y values from bottom to top, okay? So I'm going back to this. We notate with y values from bottom to top. What is our bottommost? Do what? Okay. Our bottommost y value is -2. And then it goes on forever, so that's infinity. Now, it would be included, because if I were to smush that over, it'd be an included circle. So it would be bracket, -2, comma for span, to infinity, parentheses. Now, where is this thing increasing? Now, look right here. That's decreasing. That's my decreasing. So I'm going to hold off on that because that's next in the diagnostics. Where is it increasing? Well, it starts right here at x equals -3. We denote with x values. We notate with x values. So it'd be -3, span, forever and ever. So -3 to infinity. And back to this, we are decreasing from, if I were to smush this to the x-axis, it'd be -infinity to -3. Guys, your increasing and decreasing always splits at your vertex. It always changes because that vertex is a turning point. So it's always going to change there. Now, where is this thing positive? Where does this thing lie above the x-axis? Well, that would be here, and that would be here. So, let me get my little drawing tool. I'm going to try again. This right here, that is above the x-axis. If I were to smush that, let me get a different lighter color of purple. If I were to smush that down to the x-axis, all of that would be covered. So if I took this down to the x-axis, okay, and then I have another positive interval right here, this one. And if I were to smush that down to the x-axis, let me get, oh yeah, neon. All of this would be covered. Okay, so smush this down, smush this down, smush this down, smush this down. So what are those two intervals? What are they? Oh. See, it goes away when I click that. I don't know why. It's really strange. I don't know. But anyways, it was this one and this one. So it'd be -infinity all the way to -4 because it keeps going this way. That's -infinity all the way to -4 union 2 to infinity. All right, and then where's it negative? It's negative between the two. It's negative from -4 to -2. Fun times. Now's your time to pause me and finish up your note card 61. You guys have a great day. Bye.